Welcome back to the Deep Dive. Today we're opening up a topic that I think it creates a bit of an identity crisis in the world of tech. We're looking at HomeGenie Server 2.0. And I have to be honest with you, the moment I saw the name HomeGenie, my brain went to a very specific place.
I can guess where.
I immediately pictured a smart home hub. You know the type of little plastic box you buy at an electronics store?
Right. And it helps you turn your lights on with your phone.
Exactly.
That is the most natural assumption in the world. But if we stick to that, we're going to miss the entire point of what this platform is actually trying to do.
Okay.
I mean, if you look at the documentation, the developers are incredibly specific about this. They correct that misconception right out of the gate. They don't call it a smart home hub.
What do they call it?
They define it as a general purpose automation server.
Which, admittedly, sounds a lot more intimidating. It sounds like something I need a server rack in my basement for.
It does, but they use this metaphor in the intro that I think just frames this whole conversation perfectly.
Oh, I loved this part.
They compare a thermostat to a robot.
Yes.
It's a brilliant analogy because it just strips away the physical form and looks at the logic, right?
Right.
Think about it. If you take the HomeGenie software, you install it on a Raspberry Pi, and you hook up a temperature sensor and a relay to control a heater, what have you built?
You built a smart thermostat. Simple input, simple output.
Exactly. But if you take that exact same software, the same core logic, the same code, and you install it on a chassis with DC motors and vision sensor,
You haven't built a thermostat anymore.
you've built a robot.
That is wild to think about. It's the same brain, different limbs concept.
Precisely. And that is the core philosophy of HomeGenie. It's not just about managing things like light bulbs. It's about processing signals. Input comes in, logic happens, action goes out.
And whether that action is dim the lights or rotate the robotic arm, the software just doesn't care.
It's completely agnostic.
Okay, but usually when we start talking about general purpose automation or building robots, the barrier to entry just goes through the roof. My mind immediately goes to the setup tax.
Oh yeah.
I'm thinking I need to provision a server, I need to manage Python environments, deal with dependencies, set up an IDE. I mean, it's a 4-hour project before I even write a single line of code.
And that is the hook here. That's the friction HomeGenie is trying to just eliminate. The documentation emphasizes that your browser is the development environment.
Wait, really?
Yeah, you don't need to install Node.js on your laptop. You don't need to configure a Python runtime. You open Chrome or Firefox, point it at the server, and you're writing code directly into the system.
That is a game changer. You skip the hello world setup nightmare and go straight to building.
Exactly.
So the mission for this deep dive is to figure out how this thing actually works. How do we get from turning on a light to building a custom system that's uniquely ours?
To understand that, we have to start with the foundation. The source material refers to this concept where everything is a module.
Okay, let's unpack that. In most systems, you have distinct categories, right? You have devices, you have scripts, you have scenes.
Right.
But here, they kind of blur those lines.
They do. So obviously, your physical hardware, your Z-Wave switch, your Zigbee motion sensor, those are modules. But the real breakthrough is that a piece of software code is also a module.
A virtual module.
Exactly. A device that creates data but doesn't actually exist in the physical world.
Okay.
And the beauty is the rest of the system doesn't know the difference. The best example is the weather forecast service.
Oh, right. I use this all the time. I see 72 degrees on my dashboard, but I don't actually have a thermometer hanging outside my window.
Exactly. In HomeGenie, there's a program running in the background. It fetches data from the internet, open weather map, whatever. It then takes that data and emits it, pretending to be a sensor. It creates a virtual module with a field like sender.temperature.
So if I have an automation that says, turn on the attic fan if the temperature goes above 80, it doesn't matter if that 80 came from a real sensor in my living room or a virtual one pulling from the web.
It doesn't matter at all. To the system, they are identical. They speak the same language.
That's powerful.
And this is crucial because it lets you bring any data source into your logic. You could track stock prices, server load, unread emails,
The location of the International Space Station.
and treat them just like a physical switch. If the space station is overhead, turn the porch light green. The logic doesn't care where the data comes from.
The notes also mention these modules have a parent link. What's that about?
Yeah, it's a small but vital architectural detail. Every virtual module tracks the program ID that created it,
Why?
so the system stays clean. If you delete the script that fetches the weather, the system knows to clean up that virtual thermometer. You aren't left with ghost devices cluttering your interface.
That's smart. Okay, so we can create these virtual devices. But to do that, we have to write code. And this is where we have to talk about languages. Usually, a platform forces you into one lane. You're either writing YAML, or you're writing Lua, or maybe JavaScript if you're lucky. HomeGenie seems to offer a buffet.
It really does. You've got 3 primary choices, and you can mix and match them. C#, Python, and JavaScript.
The big 3.
Yeah.
But let's go back to that no setup promise. How is it running Python if I didn't install Python on the machine?
This is where the engineering gets really interesting. They use embedded engines. For JavaScript, they use something called Jint.
Jint, okay.
It's a JavaScript interpreter that runs inside the .NET environment. And it's smart. It handles the translation, so in JavaScript you write in camel case, and it automatically maps that to the system's core API.
That's convenient. You don't have to learn some weird proprietary syntax.
Exactly. But the one that really caught my eye was the Python implementation. They're using Iron Python.
Iron Python, that sounds heavy metal.
It does, doesn't it? But practically it gives you superpowers, because it's Python running on the .NET framework.
So what does that mean in practice?
It means your Python script can import and use standard .NET libraries. You can type import system.io to mess with files, or access hardware drivers directly using C# libraries, all while writing clean Python syntax.
That is huge. You're not sandboxed into just scripting. You have access to the whole underlying framework.
Exactly. And your third option is C#. Since the whole platform is built on C#, when you write a C# script in the browser, it's actually compiled into optimized.dl files on the fly.
Wait, does that mean they're fast?
Extremely fast. And there's a note about local API calls. If one program talks to another on the same server, it doesn't go over the network. It bypasses the whole HTTP stack and just happens directly in memory.
So no lag.
0 lag. And if you're building that robot we talked about, that latency is the difference between staying upright and falling over. That direct memory access is critical.
Okay, so we have our languages, we have our virtual modules, but there was one feature in the documentation that it blew my mind. It's called feature injection.
Yes. This is one of those aha moments where you realize this is not just another hub.
It sounds like something out of a sci-fi movie. I'm injecting a feature, but basically it lets you modify devices you didn't build, right?
Correct. Imagine you buy a standard smart light bulb. It turns on, it turns off, maybe it dims. That's it.
Right, the manufacturer decided those are the features I get.
Well, HomeGenie says, no, you decide what features you get. You can write a script using program.add feature. This lets you inject a new setting directly into the settings dialog of that light bulb.
So I open the settings for my Philips Hue bulb, and there's a new checkbox there that I put there.
Exactly. The example they use is a blink feature. You write a script that says, add a checkbox called blink to all devices of type light or switch, and boom, every light in your house now has a blink option.
But checking the box doesn't magically make the hardware blink, does it?
Yeah.
The bulb doesn't know what blink means.
No, the bulb is dumb. That's where your script comes in. The script has a loop that's always running, and it says, find all modules where the blink feature is enabled.
So it listens for that check mark.
It listens. And when it sees it, the script starts sending toggle commands on, off every half second.
I see. So the script is the brain, and the checkbox is just the user interface for that brain.
You got it. And just think about the implications. You could add a night mode that caps brightness at 10%, a log usage checkbox that writes to a spreadsheet every time a door opens. You are effectively rewriting the functional firmware of your devices without ever touching the hardware.
You're adding custom behaviors to hardware that didn't ship with them. That is so powerful.
It changes the relationship. You're not just a consumer of the device's features, you're a creator extending them.
Now, I know some people listening are thinking, I cannot write C# to save my life.
Yeah.
But the source material talks a lot about visual programming, and honestly, usually visual programming feels like a toy.
It often is. Like, it's just for kids.
But here, they're comparing it to Neurons.
Yeah, this is where they bridge the gap between simple automation and AI. They describe a visual program not just as a flow chart, but as an artificial neuron.
Meaning what, exactly?
It takes an input, it processes it, and it produces an action, and you can chain them together. The example they give is fantastic. It's a robotic eye tracking a teddy bear.
Okay, walk me through this. How do we get from drag and drop blocks to tracking a teddy bear?
So imagine the first neuron. This is a program running object detection using a YOLO model. It sees the camera feed and says there is a teddy bear at these coordinates.
Okay, so that's the input. Bear found at coordinate XY.
Right. Then you have the visual program for the eye control. It receives that data, but you can't just plug teddy bear coordinates into a servo motor. You need to do some math.
Right, to turn pixels into degrees of rotation. You need to tell the motor how much to turn.
And this is where context functions come in. Even inside the visual editor, you can drop in a small block of C# code to do the heavy math. The example uses a function called followX.
So it's visual programming. But you can inject little snippets of real code where you need the complex logic.
Exactly. It's a hybrid approach. And then, this is the detail I loved, they have a secondary program running in parallel just to make the eye blink.
Just to make it blank, why?
To make it look lifelike. If it just stared at the bear without blinking, it would look robotic and creepy. So they have a separate loop running an eyelid animation program.
Wow.
It shows how you can layer these neurons to create complex behavior. One part tracks, another part manages the personality.
That really does sound like building a nervous system.
It is. It's a distributed nervous system for your house.
Right.
Or your robot.
So we've got the brains covered. Let's talk about the face. The dashboard. Custom dashboards are usually the hardest part of these systems.
They can be a nightmare.
You're either stuck with what they give you, or you have to learn some proprietary layout language.
HomeGenie takes a very standard approach here, which is refreshing. Custom widgets are built using standard HTML, CSS, and JavaScript.
The languages of the web.
If you can build a web page, you can build a widget. But there's a key technology they use to keep it safe. The Shadow DOM.
The Shadow DOM. Sounds like a villain's lair.
It does, doesn't it? But in web development, it's a protective bubble. Your widget lives inside the Shadow DOM. That means your CSS styles, your colors, your fonts cannot leak out and mess up the main dashboard.
So if I accidentally write make background pink, it won't turn the whole app pink.
Exactly. It isolates your code. And the data connection is super simple. They use these directives. If you want a text box to show the name of a device, you just add #name to the HTML tag.
That's it, just hashtag name.
That's it. And for things like sliders, they have two-way binding using @sync. So if you move the slider, it updates the system variable. If the variable changes, the slider on the screen moves automatically.
Smooth. And what about looking good? Dark mode is mandatory these days.
Of course. But you don't have to write two versions of your widget. They use CSS variables. So instead of saying background.white, you say background.var card color.
Ah, so it automatically adapts.
Right. If the user switches to dark mode, your widget automatically switches too.
You mentioned copy pasting earlier in our prep. Is there a library for these?
This is a great tip from the docs. Because it's standard HTML and CSS, you can go to sites like uiverse.io, find a button you like, copy the code, paste it into HomeGenie, add those little binding tags like #name.
And you're done. That's incredible. You don't have to be a designer. You can just shop for UI parts.
It democratizes the interface design. You can have a professional-looking dashboard in minutes.
Okay, we have to talk about the scheduler, because every smart home needs to know what time it is. But the source mentions enhanced cron expressions. Now, I know cron is that cryptic string of asterisks from Linux.
It is, but HomeGenie supercharges it. Standard cron is great for do this every Tuesday at 5, but it's terrible for do this at sunset.
Because sunset changes every day.
Exactly. HomeGenie builds in variables like at solar times, sunset, and at solar time sunrise. But here is where it gets really interesting. It allows for complex logic and arithmetic inside the schedule string itself.
Arithmetic in the schedule. Give me an example.
Okay, try to visualize this expression. At solar times, sunset plus 30 at solar times, sunrise 60.
Whoa, okay. Let's break that down. At solar times, sunset plus 30. That's
30 minutes after today's sunset. The greater than symbol here means until, so from 30 minutes after sunset
until 60 minutes before sunrise, because of the minus 60.
Exactly. You just defined a nighttime block that shifts dynamically every single day. But then they add another layer. You can add percent at holidays.summer at holidays.winter.
What does the sign percent do?
In this syntax, percent means except t.
Except, and the colon means or.
You got it.
So, from 30 minutes after sunset until an hour before sunrise, except during summer or winter holidays.
Exactly. You just defined an incredibly complex temporal logic changing daily with the sun, filtering out specific holidays in a single line of text.
That is dense, I won't lie. But once you know the syntax, it's incredibly powerful. You don't need a script with 10 if statement checking dates and times.
It treats time as a programmable entity. It's not just a trigger, it's a logic flow.
So bringing this all together, we have modules that can be anything. We have 3 languages to code in directly from the browser. We can inject features into dumb devices. We have visual neurons. And we have a time machine of a scheduler.
And you can bundle it all up. The system has a package management system.
Right, so if I build that cool robot eye setup, I can zip it up and send it to you.
Exactly. You can bundle your programs, your widgets, your custom APIs into a package. It really turns the user from a consumer into a creator.
That really is the theme here, isn't it? It feels like HomeGenie is handing you the keys and saying, we built the engine, you drive the car.
Or the robot, and that's what makes it so exciting. It respects your intelligence, it assumes you might want to do something that developers never thought of, and it gives you the tools to actually do it.
So here's my question for you, the listener. If you could use that feature injection tool we talked about, if you could add one checkbox to any device in your house, something the manufacturer never intended, what would it be? Would you add a party mode to your toaster? A silence button to your microwave?
I know my answer. I'd add a don't burn the popcorn checkbox to the microwave.
See, the possibilities are endless. Think about it, and maybe go check out HomeGenie if you want to actually build it. Thanks for diving in with us today.
Always a pleasure.
We'll catch you on the next one.